Hello students, in this video we will see the next point, matrix representation of the graph. Depending on adjacency of vertices and incidency of an edges, a graph can be represented in two types of matrices. First, adjacency matrix. If G is a graph on n vertices, say V1, V2 and so on Vn, then adjacency matrix of G is the n by n matrix. A of G is equal to n by n matrix with entry Aij, where Aij is equal to number of edges between Vi and Vj, or is equal to 1 for self loop. For example, consider following graph. Here you can see that V1, V2, V3, V4, 4 number of vertices, and this is nothing but the edges of these vertices and this is the loop. So adjacency matrix becomes, first here n is equal to 4 number of vertices, so adjacency matrix is 4 by 4. First write vertex here V1, V2, V3, V4, also write column wise. Now first entry is A11. A11 means number of edges between V1 and V1. Here number of edges between V1 and V1 is 0. Number of edges between V1, V2, there is only one edge, so put here 1. Number of edges between V1 and V3, there is no edge, so write here 0. Number of edges between V1 and V4, no edge, so write 0. Now second row, number of edges between V2 and V1 is 1. Number of edges between V2 and V2, no, there is no edge, so put here 0. Now number of edges between V2, V3, there is 1. Also number of edges between V2 and V4, 1. So write here 1, 1. Now third row is number of edges between V3, V1, V3, V2, V3, 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 V4. Here you can see that number of edges between V2 and V3, 1. There is no edge between V1, V3 and V4, V3. Also here loop means number of edges between V3 and V3 is 1. Now V3 and V1 0, V3, V2 1, V3, V3 self loop, so write 1. V3, V4 no edge, so write here 0. Now fourth row becomes number of edges between V4, V1 no edge, so write here 0. Number of edges between V4, V2 1, so write here 1. Number of edges between V4, V3 no edge, so write here 0. Number of edges between V4, V4 no edge, because here we cannot see a loop, so that's why here we put 0. If there is a loop, then we can write here 1. Now as you can see that this matrix is nothing but this symmetric matrix, because first row is first column, second row is second column, third row is third column, fourth row is fourth column. So adjacency matrix is symmetric matrix. Also you can see that if we add first row elements, we get degree of V1. Also if we add column wise entries, we get degree of V1. If we add these entries, you get degree of V2. Degree of V1 is 1, here 1, here 1. So addition of elements row wise or column wise, we get degree of that corresponding vertex. Observation of adjacency matrix is nothing but the first, the sum of the entries in the ith column or ith row gives the degree of vertices Vi. Diagonal entries counted twice, because diagonal entries, this diagonal entry is nothing but the loop. because here V3, 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 we put 1. But if we count a degree of vertex, then we count loop as a twice. So diagonal entries counted twice. Second, Aij is equal to 0 if and only if there is no loop at Vi. Here you can see that there is no loop at V1, V2, V4. So these entries, these are nothing but the diagonal entries: A11, A22, A33, A44. A11, A22, A44 is equal to 0 because V1, V2 and V4 has no loop. Here V3 has a loop, so here we write 1. Third observation is, since the number of edges joining Vi to Vj is equal to number of edges joining Vj to Vi. Here you can see that number of edges between V1 to V2 is 1. Also V2 to V1, 1. Similarly V3 to V4, 0, or V4 to V3, 0, and so on. So Aij is equal to Aj, and this is nothing but the condition of symmetric matrix. Therefore adjacency matrix is symmetric. Fourth observation is, if G is a simple graph, then adjacency matrix is matrix containing zeros and ones, because simple graph means there is no loop and no parallel edges. So it containing only zeros and ones of that adjacency matrix. Binary matrix in which each diagonal entry is 0, because simple graph does not contain a loop, that's why diagonal entries becomes 0. Second matrix is incidence matrix. Incident matrix means if G is a graph with n vertices, V1, V2 and so on Vn, and m edges, E1, E2 and so on Em, then the incidence matrix of G is denoted by capital I of G, as I of G is equal to n by m matrix with entries Aij, where Aij is equal to 0 if Vi is not incident with Ej. Aij is equal to 1 if Vj is incident with Ej, and Aij is equal to 2 if Ej is a loop at Vi. Here you concentrate on loop. In incident matrix, for a loop we write 2, and in adjacency matrix, for loop we write 1. Now example of incident matrix is, for example, here graph G. Here you can see that V1, V2, V3 are the vertices of G, and E1, E2, E3, E4, E5 are the edges of the graph G. First write edges and next column wise write vertex. Here n number of vertices means 3 number of vertices and 5 number of edges. So matrix becomes 3 by 5. First write column wise edges E1, E2, E3, E4, E5, and next write column wise V1, V2, V3. Here you can see that E1, E2, E5 are incident on V1. So write first row in E1 column 1, E2 column 1 and E5 column 1. Other entries becomes 0. For V2 second row, here you can see that E1, E2, E4, E3 are incident on V2. So for E1, E2 write 1. For E3, E3 is a loop, and for loop we write 2 in incidence matrix. So write here 2. Also E4 incidence on V2, so put here 1 and other entries becomes 0. For third row, for vertex V3, here you can see that E4, E5 are incident on V3. So write for E4 1, for E5 1 and other entries becomes 0. Now observation of incidence matrix is, first, each column contains exactly two ones. 1 2 1 2 2 1 2 1 2. Second, the sum of the entries in a row indicates the degree of the corresponding vertex, similar as adjacency matrix. Third, if two columns are identical, then the corresponding edges are the parallel edges. Here you can see that first and second column are identical. Then the corresponding edges E1, E2 are parallel edges by definition of parallel edges. Fourth observation, if a row contains only zeros, then the corresponding vertex must be an isolated vertex, means that degree of that vertex is equal to 0. Next observation is, if a row contains a single ones, the corresponding vertex must be a pendant vertex, because definition of pendant vertex is degree of that vertex is equal to 1, then we can say that that vertex is pendant vertex. And next observation for incidence matrix is, if an edge is a loop, there will be a single 2 in the column containing entries being zeros. In this video, we have seen how to write adjacency matrix and incidence matrix. Now here we stop.